Hello, this is E.J. Daigle, Dean of Robotics and Manufacturing, Industrial Engineering 4250, Industrial Automation. So today we're going to talk a little bit more about CNC programming. Again, I'm not a machinist. I will tell you this is a good introduction to what CNC machines do, but in no way, shape, or form are we trying to machine finished parts in what we're learning today. Specifically, we're going to talk a little bit about CanCycles. So let me mention what a CanCycle is. So CanCycle, big long description here, but if I need to drill a bunch of holes, if I need to tap a bunch of holes, boring, engraving, pocketing, there's something that I know I'm going to do all the time, rather than having to write every single line of code. A CanCycle, kind of like a subroutine in other programming languages, allows me to basically predefine some of that code and just change the variables. So as an example here, you'll see I have some holes here, 1, 2, 3, and 4. All 4 of those holes are the exact same diameter. All 4 of those holes are the exact same depth. You can actually see the depth here as well, right? So rather than having to go to each X, Y, and then go, down in Z and then back up in Z, and then another X and a Y and down in Z and back up in Z, what a CanCycle do, like a drilling CanCycle, what it would allow me to do is just say, look, I need to drill 4 holes. Here's how deep I want them. Here's how much out of the part to clear to get to the next hole I want you to go. And all I'm going to send you are the XY locations. Can you go drill those 4 holes for me? Just like you would if you were telling a person to go drill those 4 holes. You'd say, hey, here's where I need these 4 holes. Here's the depth. You wouldn't say, okay, I need this hole here. Drill it, go down negative Z here, go positive Z here. And then I need you to go to a different location, go negative Z, positive Z. No, you just would tell them, here's where I need the holes and here's the depth they need to be. That's what a CanCycle really allows you to do. So we'll talk about a G81, but like I said, many of these CanCycles, you can, if you type in Haas, CanCycles, you'll find the ones for engraving, which are really, really handy. You can just type in the letters you want to engrave and the font size, and it just engraves it for you. Tapping, so on and so forth. But we're going to do the drilled CanCycle, probably one of the most common ones that you'd run into. So first off, I'm looking at a line of code for the CanCycle right here. There's G81. G81 right there. And so that's going to be my call out for my CanCycle. Okay. G81 designates the type of CanCycle it is. And G81 in this particular case means it's a drilling cycle. The Z minus, so that's what G81 is. The Z minus 0.72 right here, Z minus 0.72, tells me the depth of each hole. Okay. The R 0.1 tells me the clearance above the part. So after I go into the part, so as my drill is going down into that part, right, my drill is going to go down and cut into that part, how much do I have to clear here before I can go over to that next hole, right? That clearance is 0.1. That's how much above the part I'm going to get in between each hole. And then this is just the feed rate at which I'm going to cut into the material. The part that's the goofiest about the whole CanCycle routine, let me erase this real quick here, or the part that I think is the most difficult to understand maybe, is I'm actually drilling 4 holes here, but you'll see that I've only called out 3 holes, the second, third, and fourth hole. So really what I've done is I've gone to that first position. I've set up my speed. I've set up, my tool offset. I've turned the coolant on. I've called G81. And so if I was looking at where these holes are, if this was my part, let's say, and this is 0, 0 right here, we go 1, 2, 3, and 4, 1, 2, 3, and 4. That first hole is actually, oh, I'm on the wrong part here. Give me a second here. I'm going to fix my little diagram here. I can see I've got some negatives in here. I got to go on the other side of the axis here. All right, so where are we at here? Pointer options, pen, there we go. So I need the X in the positive direction, the Y in the negative direction. So I guess I'm going to look kind of like this. So here's my X. It's the same thing. I mean, it doesn't really matter just how your machine is set up. So 1, 2, 3, and 4. 1, 2, 3, and 4. So that first hole is going to be at X2, Y negative 2. This would be the location of my first hole. Now I actually called that out way up here, didn't I? That's where I actually called out that first hole. All right, I don't want to leave parentheses in there and make someone think that that's a comment. So let's get rid of those. But that is the location of that first hole is what you're looking at right there. So then we'll call that hole number 1. And then I go to x2, y negative 4. That's going to be down here. That'll be hole number 2. x4, which will be over here, y negative 4. This will be hole number 3. And I'm going to assume the other one's going to be up here, hole number 4, which is x4, y negative 2. So that's where my 4 holes are going to be. But again, remembering that this is actually the location of that first hole. Even though I'm calling out here, I'm going to drill that first hole where I'm located. And then I'm going to go, so that's hole number 1. Then I'm going to go to hole number 2, hole number 3, hole number 4 after the G81 call out. So G81 call out is going to be based upon where I'm starting, and that's where it's going to put that first hole. And then it's going to move to that next location. Now you can see though, this is really convenient because I didn't have to call out that Z, right? The Z plus and the Z minus are built into the G81. And all I'm calling out are the next locations that I need to go to. So really, really convenient tool for drilling, tapping, or any place that you might need this. All right, so we've got a part here now. Now I'm in the upper right quadrant here, so everything will be positive just for the ease of use here. I can see my materials aluminum. Tool 1 is a 4-flute end mill. Tool 2 is a quarter-inch hole, so we'll say a quarter-inch drill. So now I need some feeds and speeds is what I need. So let's go calculate those first. I'm going to go to the next slide here, and I probably want to know what these are. So the material's aluminum. So I'll write material, and I'll write aluminum. All right, tool 1 is a 4-flute end mill. And I think it was a 1/4 inch, right? Let's just go back and look for a second. End mill, yeah, 1/4 inch end mill. And then this tool 2, so this was tool 1. Tool 2 then is a 1/4 inch drill. That's all the information I need to calculate my feeds and speeds. So 1/4 inch end mill, 4-flute, 1/4 inch drill, and I'm working with aluminum. All right, so let's do my end mill first. So we'll talk, this is my end mill. And so for my end mill, RPM equals the cutting speed times 4. I'm going off of this equation right here, over the diameter of the cutter. So now what I need to do is I need to go find my cutting speed. So again, I'm on aluminum. I'm using an end mill, so roughing, I'll do 240 times 4, divided by the diameter, which is a 1/4 inch, 0.25. Oop, messed that one up pretty good there. It's the only dilemma with this little tablet I'm using. Pointer, just got to change between the tools every once in a while. 0.25. Type this into my calculator real quick. So 240 times 4 equals that, divided by 0.25, I get 3,840. So my speed is going to be 3,840 RPMs. My inches per minute, or my feed rate, is going to be, I'll make some room here. I'm fine. Inches per minute for my end mill is going to be FPT times N, which is the number of flutes, times my RPM, my speed. If you're unsure where I'm getting that from, that's actually coming over from here. So my inches per minute. The feed per tooth. So for aluminum, I'm right here, and I am a 1/4 inch end mill, which will be right here, aluminum. Feed per tooth is going to be 0.002. I'm going to multiply that by the number of flutes. The number of cutting teeth, number of flutes. In this case, I've got a 4-flute end mill. So multiply that by 4 and multiply that by 3,840. That'll give me my inches per minute, or my feed rate. For this case is 0.02 times 4 times 3,840. 30.72. Go back into my slide here. 30.72. So I've got those two guys available to me now, 3840 and 30.72. Now you want to be careful, because remember, this is just for my end mill. This is for what I would call tool 1, right? This is tool 1. Tool 2 was my drill. So those are two different cutters. They're going to use different feeds and speeds. Now the nice thing though is they're going to use the same equations, so we don't have to relearn equations. So RPM is still equal to cutting speed times 4 divided by diameter. Now the cutting speed for a drill, I'm still working with aluminum, and I'm going to assume a high-speed drill or a high-speed steel drill. Unless I tell you it's carbide, you can always assume high-speed steel. So that'll be 200 times 4 divided by 0.25. Okay, so I'll bring up my calculator here. 200 times 4 equals that, divided by 0.25 equals 3,200 RPMs. Let me find my little mouse here. There we go. 3,200. That's what we have there. That's my RPM. My feed rate, my inches per minute, again is going to be based upon this equation here. So we've got feed per tooth times the number of cutters times RPM. We're going to make one big assumption when we're using a drill. We're going to call this one flute. We're not going to, it's going to be always based upon 1. Our feed per tooth, so these are our feeds up here. When we're doing a drill with a 1/4 inch tool diameter, you can see it's 0.005. 0.005. We're going to multiply that 1. There's one cutting edge that we're worried about. And our RPM that we had just calculated was 3,200. So this is going to give us our inches per minute. I'll write down here. I'll hit my calculator button, and we'll say 0.005 times 1 is 0.005 times 3,200 equals 16 inches per minute. Oops. Scrolled ahead there. Sorry about that. 16 inches per minute. So now I have both my feeds and my speeds for both my end mill. So these two guys are my end mill. And then these two guys here, and here are my drill. My RPM and my feed. Now I can use that as I want to start defining what this code is actually going to look like and how I'm going to make this thing work. So let's see here. I think that the best thing maybe to do would maybe be for me to bring up a notepad document on the side here. I'll keep my annotations because I feel like I don't want to lose those feeds and speeds calculations that we just did. So I'll bring up what's called Notepad. I'm just going to write my code right in Notepad really, really simply. I'm going to, what I'd recommend you folks is put your name inside some human readables here, some comment type stuff. I'm going to call this my G81, my G81 demo. And what I'm going to do with this demo, as you look at this, is I'm going to trace out this path here. So let's bring up another slide here. So I'm going to go from this point with an end mill, which is 1, 1. I'm going to go over to this point with my end mill, and that's going to be 1, 2, 3, 4, 5, 1. Then I'm going to go up to here with my end mill, and that's going to be 5, 3. Then we'll go all the way over here to 1, 3. And then I'm going to go back to 1, 1. So the first thing I want to do is I just want to cut out whatever this trace is. I'm just going to show that I can follow these tool paths. This isn't necessarily a finished part. This is really just learning the code. So I'll get out of there, keep my annotations again, so I know what those numbers are. That's going to come in kind of handy. I should probably just go ahead and label those other numbers too. This whole location here is going to be at 2, 2. This whole location is going to be at 3, 2. And this whole location is going to be at 4, 2. And this lends itself perfectly for a can drilling cycle. Why? Because we're drilling the exact same hole with a 1/4 inch diameter and a 1/4 inch depth. So there's no sense in calling all of those individual features out if I can just call up that CanCycle. And you can see the more holes you have, the more valuable that CanCycle is going to be for you. I think when you get 3, that's about the right number where you're feeling like, boy, it'd be nice not to have to call out all of those movements. All right, so let's go ahead and go into Notepad real quick. I'm going to open up Notepad. Got some stuff going on there. There we go. All right, slide some stuff out of the way here. And so what we're going to do is we're just going to start writing our code here for what we need for these tool paths. Again, remember we got to go around the outside of the part with the end mill and then drill these 3 holes in the middle. So we'll start off with our %, which is always how we start off our program, kind of our handshake routine. Then 00001, that'll be our program number. I'm going to tab over a little bit. I'm going to put in my name just as a program comment here. I'm going to call this G81 demo. This is just the human readables that we can look at and try to make sense of what this is for. Next thing we're going to do is we're going to have our safe line. Pardon my slow typing here. G80 and G90. And let's go over here. We'll call this our safe line. We'll just talk briefly about some of these. I don't need to get into all of them. We've talked about the safe line before, but we're setting up for rapid right off the bat. G17 is the XY plane. I think, you know, some of these we'll talk about more later on, but probably the biggest one that you're going to see here that is applicable to what we're doing right now is G80. G80 is actually the CanCycles. And so we're going to use a CanCycle. And then G90s are our absolute positioning. So again, safe line puts our program in a known condition, so we're off and ready to run. The next thing we're going to do is we're going to select that first tool, T1M6. So I got to go back and look and say, what is tool 1? Okay, well, tool 1 is actually my 4-flute end mill. So I'm going to go over here and I'm going to write 4-flute 1/4 inch end mill. And so that's a tool change to tool 1. We're all set. Next thing I'm going to do is I'm going to rapid. And I will rapid to the first location for the end mill. And remember, the first location for the end mill is going to be 1, 1. And then we're going to cut around this outside edge. So I'll go X 1.0, Y 1.0. This point we want to turn the spindle on, so we need a speed. I don't remember what my speed was. I'll click over here. Speed for the end mill was 3840. That looks good. So speed of 3840. The spindle on command is M03. So this will be spindle on clockwise. All right, so now our spindle's on and we're ready to start cutting. So before we do though, we should always have a G43. If you remember what a G43 is, that is actually our tool length compensation is what G43 is. So in this case, we'll give it height 1. This will be actually a touch off that you'll do with that tool so that the machine actually knows how tall that tool is. And we'll set ourselves up at 0.1 above the part. So I'll just call this tool length. It's a height command there. I'm going to turn on M08. This will be coolant on. And then we can go ahead and start cutting. So I'm going to go back to where I'm looking here. I need to dive in Z minus 0.1. So we're going to dive in 0.1. We're just going to be kind of cutting around this outside rectangle is what we're going to be doing. So that's a linear interpolation, G01. We'll go Z minus 0.1. Now I need to know how fast to feed that cutter into the material. So I do need to bounce between slides. You can see how there's a lot of data that we need to pull out of our calculations. My inches per minute is how fast I want that end mill to cut in and through the part there, 30.72. I'm not going to do the 0.72. Typically we just do a feed rate to 1 decimal point, 30.7. And then we're going to go to our various points. So we're starting off, we're already at X1, Y1. The next location would be X5, Y1, X5.0, Y5.0. And then we're going to go to X5.0, Y3.0. Oop, I didn't get Y1 there. Careful. All right. And then X5.0 and Y3.0. And then X1.0 and Y3.0. And if we were in incremental versus absolute, we would only be calling out the axis that's moving. So like X is moving 4 in this direction. But in this case, in absolute, we're going to call it both of the XY points. And then the last one, make sure I close that loop, is X 1.0 and Y 1.0. So that takes me all the way around that rectangular shape that we just called out. And if I'm done with that, I probably should come up out of the part. So G00 will be the rapid out of the part, and I'll go to Z0.5 or some number. That's going to bring my tool up out of the part. So I've cut the rectangle, feel pretty good about that. So now I need to change tools, and I need to start drilling the holes, and that's where I'm going to use that CanCycle. In order to do that, though, the first thing I need to do is I need to do an M05. And an M05 will stop the spindle. So this is a spindle stop. An M09 will turn the coolant off. That's probably a good idea right now, too. We're not cutting. Then we're going to switch to tool 2, T2 M06. And it just reminded me up here, I just did T1 M6. I'm going to do M06, so I keep my M's kind of similar there. I don't think it would have mattered here, but and this point we're going to call the 1/4 inch drill, which is tool 2, 1/4 inch drill, tool 2 M6. We can turn that coolant back on if we like. So the coolant on. I don't need to type that. We know M08's coolant on from up above. And now what we're going to do is we're going to rapid to that first hole location. So very similar to what we did here, where we rapided, we ran rapid as fast as we could to this location. Now that we're above the part, we're going to rapid as fast as we can to 2.2. So we're going to use almost that exact same chunk of code. I'm just going to copy it, except we're going to go to 2.2. And I'm pretty sure our speed is not going to be 830, 840. So remember, we now have a drill as our cutter. And we did the calculations for that drill a few minutes ago. So let's go into those. Calculations for our speed is 3,200 for the drill. Oops, let's go back into the notepad here. So our speed is going to be 3,200. And we need to turn the spindle on. And again, you guys can look up here and see what those are. Again, I'm not going to show those every time. So now we've got our cutter above the 2.2 location, which is right here, and the spindle's turning, and it's ready to start drilling holes. All right, I'm going to leave us there. Go back into my notepad here. That all looks good. Now, the next thing that we did on the end mill was we set our tool length compensation. So that'll be a G43, H02, and a Z0.1. If you don't recall what this is, the reason why we're H1 up here is that's the height offset for tool 1. This is the height offset for tool 2. So that's where we would actually touch off and tell the machine how long that tool is. All right, I feel pretty good about that right now. And this is the meat and potatoes now. This is where we're going to call G81. All right, let's go back and look at what G81 is. G81 designates the CanCycle for drilling. If I want to drill a bunch of holes, I can call G81 once, like I did right here, and then I can just list the locations. So that's exactly what I want to do. I want to call G81 once, and then I want to list these locations. All right. Now, the one thing that's a little bit goofy is our first location is already given. We're already above 2.2, so that's going to be, I'm actually going to call that here. That's going to be called hole 1. Mind you, we're not going to drill that hole until I call G81, but the first hole is the position where you are currently at. Then I'm going to tell it how deep to drill it. -0, I forget what it is. There we go. Z a -1/4, -0.25. And then I need an R, if I remember right. Let's see, yep, a R, which is the clearance above the part. How high above the part do I want to go to clear the part? I'll do an R of 0.1. And then I need a feed rate. So I've got my speed right here, but now that I'm drilling, I need to know how fast I want that cutter to drill into the material. So again, I got to bounce between slides, go down here and look at my feed rate is 16. for the drill. So feed is 16.0. So up there I had a feed rate of 30.7. Now I have a feed of 16.0. So this is my G81 CanCycle. This is my canned drilling cycle. What that really means is it's a pre-built routine that you can just call. You've already called the first hole, 2-2. Now we're going to call hole number 2, and it's as simple as this. X 3.0, Y 2.0, X 4.0, Y 2.0. And just like that, you've drilled 3 holes. You haven't had to call Z again. You haven't had to, change speeds and feeds. And for that matter, I could keep going. I could just list a whole sequence of holes. I could put a dozen, I could put 20 holes. And I could just drill them all with that canned drilling cycle. Now, remember G81 is a modal command. What that means is if we turn it on, we better turn it off. And G80 is our cancel of the CanCycle. And just maybe to help myself out here, this was hole 2. This was hole 3. And this was my my cancel of the drilling cycle. So let's just copy this, Control C, and instead of saying can drilling cycle, I'm going to say cancel can drilling cycle, because that is a modal command. Now that G80 has turned that off, it might be good to call M05, which is going to stop my spindle, M09, which is going to turn off my coolant, M30, which is going to mark the end of my program, and the % sign to physically end where the code is here. That's our little handshake there saying we are done. I'm going to take, actually I better save this first. Save as. I'll call this G81 demo. And then I'm going to copy this code real quick. And I'm going to open up the NC Viewer platform. And NC Viewer is going to be your best friend, folks. Yep, I didn't get it there. NC Viewer. There we go. Because it allows you to manually look at this code. So I'm going to go ahead and delete all this junk. This is just like directions for NC Viewer. I'm going to paste my code in there. And I'm going to make it a little bit bigger so we can see it maybe a little bit better. There we go. And I'm going to plot it. There it is. Now, this looks a little funky. Obviously, the blue represents a cut, the rectangular cut. That looks great. And then I can see my cutter goes up, over, and back down again, but I don't see it drilling holes. What I want to tell you about this G81 is NC Viewer is really good at just following X's, Y's, and Z's and moving around on a toolpath. When it comes to some of the CanCycles, it will move to the positions, but it won't necessarily engrave. If it's an engraving CanCycle, it's not necessarily going to tap, it's not necessarily going to drill. So you just got to keep an eye out for that may be the case. I'm going to just go through this real quick. I'm up at the top. I'm going to highlight line 1 here, and then I'm just going to hit my down arrow. And I can watch what's happening to my cutter. You see it move over to the 1-1 position. And then it goes, sets the tool at 0.1. And then it dives down into the part. And now it's going to trace around that rectangle. Boom. In mill's done. I go back up. I change my tool. And again, it's not going to change tool. It's just going to look like a cutter to you. The coolant, the spindle, the whole 9 yards. I go to this location and I dive down into the part. That's my 2-2, my 3-2, and my 4-2. Now what it's not going to show you, which I wish it would, is I wish it would show you the R, meaning going up to the clearance plane and cutting over to the next one and then going back down. But unfortunately, all it's going to do is show you those 3 locations, and you can change your view if you like and kind of bounce between those 3 locations as well. And then you can verify that indeed that is 2-2, that is 3-2, and that is 4-2, and then back up and out. So you get an idea, and I probably should go home at some point here as well. Maybe I want to go after I've done my cancel here. Maybe I want to do a G01 and go X 0.0 and Y 0.0 or something like that, and then go to plot. And probably should be careful with that. Probably don't need a G01. Probably can do a G00. There we go. So, but again, gives you a nice little example of what this cutter is actually doing. And I can kind of follow it all in space. I'm kind of in a funky view right there, but there we go. That's a better view. But basically hitting all those different points, going around the rectangle, hitting those 3 drill holes with my different cutters, my drills, and then going back home at the end. So I hope that was a good introduction to CanCycles. And when you get into the worksheet for this week, or the homework for this week, it's going to be basically the same thing. You know, what's the purpose of a CanCycle? Calculate feeds and speeds for tool 1, calculates feeds and speeds for tool 2. You'll see I give you aluminum material, tell you which. Actually, it looks like I did the same. Probably should have changed that. You may actually get some of the feeds and speeds calculations for free. So if you actually watch the whole video, that'll be nice for you. Sorry about that. Or maybe I'll just change one of them right now. Maybe I will drill with a, let's see here. Maybe I will drill with a, instead of a 1/2 inch or a 1/4 inch, maybe I'll drill with a, let me see what we got that's handy here. We'll drill with a 5/16 just to make it a little bit different, so you can't do the exact same thing. And then I'll save that, and I'll leave the end mill as a 1/4 inch 4 flutes, so you guys can work with that. You can see I changed the tool paths, so you will have some circular interpolations, but nothing difficult. I kept a nice radius there, so you don't have to change radii. And then in 4 locations of the hole, going down -0.3 for the drilling of the holes, and then going down -0.1 for this outside tool path that goes all around. So I wish you luck, and if you guys have any questions at all as you're working through this material, do not hesitate to reach out to me. Thank you.